What's going on, guys? This is a quick tutorial on topographies and how to effectively bring them into Revit without any mistakes. So the first thing you want to do is open up the CAD file. I have mine open in front of me. You'll then want to check that you have northing and eastings. You have station points. You have heights of each level of the topography. You have cover levels for manholes, and you have a table which tells you at a specific station what the coordinates are. Now what we're going to do is we're going to find these coordinates. We're just going to pick one of them for now and find out if the CAD file is in the correct place. So we got station 5AB here. We go to station 5AB, we click ID. You'll see that the coordinates exactly match what was on screen. It's paramount that you check this, because if the CAD file is in the wrong place, you'll then need to move the CAD file. That's for another tutorial. You need to move the CAD file to the correct place so that when you bring it into Revit, you know that the CAD file is being brought in correctly. Now, the reason we use topographies are for many different reasons. One is for once planning is obtained, a site setup engineer will take your file with your new build project and lay the site out according to the coordinates. That's number one. Number two is drainage engineers need to see the correct levels on site to make the falls of the underground drainage. These are a few things that people use the topography for, i.e. architects will use them to set out the site so they can draw a new build project in the correct location as well. So let's get into Revit and see how to bring this in. So I've got my template open. You may have a different template. I highly suggest that you link the CAD file. Do not import the CAD file. There's two reasons I say this. One of the reasons is if you bring in a CAD file as an import, if you make any changes to your CAD file, those changes won't appear. You will need to re-import the CAD file. If you link the CAD file, you make any changes and you press reload those CAD file, those changes will appear in your Revit file. The next issue is with import CADs. Number one, it makes the Revit file very big. And number two, if you explode the CAD file, you have all the text, you'll have all the line weights from CAD. So you'll need to clean the CAD up, you need to clean the Revit up, which can be a daunting task. So I highly suggest that you link it. Now, the first thing you need to do is change your view scale to 1:1 if that's what your topography is in. That's what ours is in, so we're going to use 1:1 here. Then the next thing you need to do is type in UN, go to common, and make sure the length is the same as your CAD file. If you're using meters in your CAD file, then it'll be meters. If you're using inches, it'll be inches, so forth and so on. So in our case, it's meters. I'm going to link the CAD file now. I highly suggest that you save it in a correct location. I've used my desktop for now. The next thing is choose how you want the CAD, the topography to look. So you can preserve the colors so it look like the CAD file, or you can have it black and white. It's entirely up to you. I'm going to preserve the CAD file colors for now. The import unit should be set to meters or wherever your CAD file was drawn in. And then I place it on the ground floor because that's where the topography was done. It should import into Revit, sorry. As you can see, I have the topography within Revit now. Now there's two things that are very vital here. One is your project base point, and two, this green and red arrow is your internal origin. We'll come to this when we get to the elevation shortly. These are two vital elements. The internal origin is your 0, 0 of the project within Revit. You have your orientation over here. We have true north and we got project north. The difference between the two is true north is actually the position of the building. Project north is how you want the building to look, as in facing within the Revit. So i.e. if you want to put it on sheets and you want the building to look straight, that will be your project north. Simple terms. Now, the first thing we need to do is we need to make sure we have those correct coordinates. What I usually do is I usually move my project base point to the northing and easting corner where the northing and easting intersects. Now, it's very vital that you check your units again, make sure they're meters. We're going to go to Manage tab. We're going to go to Coordinates, and we're going to specify a coordinate at a point. Now, you can tab to find the corner. I've selected the corner now, and in here, we're going to type in our northing, which is 183200, and our easting is 525700. Now my northing and easting is set up in this location correctly. The next thing we need to do is change the scale to 1 to 50 or 1 to 100 so you can read the spot coordinates when you put it in. Go up to this align dimension, click spot coordinates, and now we need to see the coordinate at each intersection to see if they match up correctly. As you can see, the first point's done correctly. We now need to go on to the next point. Our eastings are set up correctly because it's only showing us eastings. So that's correct as well. I would highly advise to pick another point just to make sure that your eastings are set up correctly here. And they are. I'll then go to the northing and see if they are set up correctly as well. And they're bang on as well. Now let me show you an example of what could happen if you use a different dimension than what was on your CAD file. So if I type in units and put it on millimeters, we know the CAD file was set up as meters. Now we put it on millimeters. If we specify coordinates at the point again, and this time we'll put in as we see. This point is correct right now. You'll see this is reading completely different now. That's how you know you've made a mistake with your units. So always set up your site correctly to the CAD file. It's paramount that that's set up correctly before you proceed further with your work. I'm just going to Control Z on the work that's happened just now. So now we know the CAD file and the Revit file have the same coordinates. The next thing we're going to do is we can either draw the topography or we can start drawing our walls. I'm going to draw the topography to show you a few things that can happen. So we go to Topo. I'm going to make this very simple for now. I'm going to use 32.69 at each location just to draw a quick topography of this site. Okay, that's 32.69. Let's go to an elevation so I can explain this to you in further detail. This is your internal origin of your project. This is effectively the 0 point of the project. For example, let's move this to there. As you can see, the elevation set at 33 because the internal origin is 0 as well. So that's reading correct. If you go to Manage, relocate the project. For example, we're going to move this down. Say we have our project base point, which is not on the internal origin, and it's down here, for example, argument's sake, or make it minus 1000. That's too much. Let's make it just minus 10. we know the internal origin is 0, 0 here, and that's at 10. So now our elevations are showing the level is 56. However, we can see our topography over here, and we know if we edit the surface, we click one point, that's drawn at 32.960. So why are we getting a different point and a different level? Now the reason is everything in Revit is drawn from your internal origin. Your levels are based on your project base point, and the topography is based on the internal origin, which is your 0, 0. These arrows are your 0, 0. So now this is incorrect. Now if I move our project base point to the internal origin, which is our 0, 0 over here, you'll now see that this is 33, this is now 33, and that's correct, because if we click into the topography again, you'll see that that's been drawn at 32.96, and that's correct for where it is. And let's make this a bit more clearer. Let's take this down to 30. As you can see, that's 30, that's 33. There's a 3 meter difference between the two, and that's how it's shown in Revit. It's shown correctly. There's other things that you can do. For example, let's go back to this. These are contour lines. You can actually tell Revit to give you the readings at each contour line. So to do this, let's go back. You go to Massing, and then you go to Label Contours. These are your contour lines. So I'm going to draw an area here. And you got your contour lines. It's showing you 33, 33, 32, 31. If I do it this way, again, you'll see they've given you the contour lines. That's it in a nutshell to bring in a topography correctly in Revit and specifying the coordinates correctly. Now, for example, if you want a coordinate at this place or at any corner, you can now just select the corner. You know you've selected it properly, and it will pull out the correct readings for you. Revit can do this at any point required, so long as it can read it. I hope you enjoyed this tutorial. Thank you very much.